All right, so 4.2, we are solving linear equations, which most of y'all do pretty well at this, so this should be pretty easy. We'll solve linear equations. Solve linear equations containing fractions, which become very easy with these calculators because it does all the fraction stuff for you. Identify equations with no solution or infinite many solutions. And where is the, so that I can write on this. All right. I need to be able to write. Where is the, well, I thought I would be able to write. But it is not showing up. Oh, maybe I can just do this. Let's try this. Annotate. All right. Go down to the next. All right. So, all right. A linear equation in one variable x is an equation that can be written in the form. This is what I call the one-step equation or two-step equation. This is a no-brainer. Once we get to this point, solving an equation, everybody needs to be able to do it. It's just you simply add or subtract a number, and then you divide by the number in front of the x. All these equations we want to work down into this two-step no-brainer equation so that we can solve it. And remember what solving an equation is. It is basically telling you what value or values of x would make that statement true. So if you look down here where we have 4x plus 12 equals 0, that's a linear equation, right? And we want to know what value of x would make that true. And if we have 4x plus 12 equals 0, this is in our two-step equation format where we would just have to subtract the tag-along number, the constant, and then I'd have 4x equals negative 12. Then you divide by the coefficient of the x, right? Whenever we're solving equations, we essentially go through and do the opposite of what they had done. They had added 12, so we subtract 12. They had multiplied by 4, so we divide by 4. And we get x equals negative 3. Okay? So that's the gist of what we're doing today. So that's the one I just did. And apparently that annotating does not go away, so I need to clear it. Okay. So that's the one we just did. Subtract 12, divide by 4. Once you get to that point where you got a term with a variable, plus or minus a number equals a number, bam, bam. We ought to be able to do that real quick. Add or subtract, then divide. Okay. Most of the ones we do will be able to work down into that certain point. Okay. All right. So next, simplify. Here's just some steps. You don't really need to write this down. Simplify the algebraic on each side by removing grouping symbols. So if we have a linear equation, you look at each side of the equal sign, you simplify, which means get rid of parentheses, combine any like terms, like we did last lesson. Then we want to get all the variables to one side. So you take the variable on, it doesn't matter, but I usually go from the right to the left. Add or subtract the opposite of whatever the variable is on the right. And then you're generally back into that two-step automatic be able to solve equation. So next we should just have, so here's, doesn't get much harder. This is basically what we're doing right here. So you're asked to solve the equation. What value or values of x make this a true statement? Okay, so here's the steps we go through. First off, you always simplify each side of the equal sign, which means get rid of parentheses by distributing whatever's in front of it, and then combine any terms that are alike. So the first thing I have to do is I have to distribute the 2 to get rid of that parentheses. So this becomes 2x minus 8 minus 5x equals negative 5. All right. Then still on the left side. Now, I don't start doing the opposite of things until I start working things across the equal sign. I still have to simplify on the left side. I have to combine the x's. Here's an x term, here's an x term. So I have to say 2 minus 5x, which is negative 3x, and then minus 8. People forget to drop down that negative, that minus sign, equals negative 5. Now we've worked it down to our simple two-step. Add 8, divide by negative 3. Add 8, and I get negative 3x equals 3. Divide by negative 3, and I get x equals negative 1. We could check our answer by substituting negative 1 back in for x, but I'm not going to spend a lot of time doing that. Okay? So simplify each side of the equal sign. This one only had a variable on one side. Maybe the next one, let's clear that off. All right, now here we go. Here's another one. Clear all drawing. All right, so same thing. This time we have variables on both sides of the equal sign. Same rules apply though. Each side of the equal sign has to be, I have to keep them separate, and I have to simplify each side. Here I'm going to distribute the 2, so that will become 2x minus 6, and then minus 17. And then I need to combine the constants 6, negative 6, and negative 17. So 2x, negative 6 minus 17 is a negative what, 23? And then over here, I have to distribute that negative 3. Make sure we distribute negative 3. So that's going to be 13 minus 3x minus 6 once I distribute that negative 3. And once again, my constants need to combine. Now I'm going to drop down that negative 3x. Don't forget the negative. People tend to drop that off. 13 minus 6 is positive 7, so that'll be negative 3x plus 7. Now, I've got it simplified on each side, but I've got variables on both sides. Now, you can go either direction. I could subtract the 2x and move the variable over to the right. I always like to bring it to the left. So I'm going to add 3x to both sides. The reason I do that is because that there will add to 0, and it will do away with that term. And I'll just be left with 7, and then that will be 5x minus 23. And notice where we are now, the simple two-step. Add 23, divide by 5. Add 23, and I'm going to get 5x equals 30. Divide by 5, and I'm going to get x equals 6. And that's my answer right there. Okay, y'all have all done this for many years. Okay. Any questions? That's the one we just did. All right, now what do we do with fractions? Well, the nice thing about these calculators we have in class, they have fractions on there. So this is absolutely no different. Okay, 7/2 equals 1/9 x plus 26 over 9. All right. Some books will teach you how to eliminate the denominator by multiplying everything by a common denominator. But because we have calculators that handles fractions, then there's no reason to do that. What we have to do is, this is just a simple two-step, right? Just like that, if that were 7 equals 1x plus 26, we would subtract 26 and divide by 1. Well, what I'm going to do is I'm going to subtract 26 over 9. Now, if you don't if you don't like the variable on the right side, some of you don't care, some of you like it always on the left, what I can do is I can just rearrange this without changing anything. 1/9 x plus 26 over 9 equals 7/2. You can always do that. You can always just flip the equation around. I'm not changing anything. I'm just putting what was on the left on the right, what was right on the left. All right. But I would still subtract 26 over 9 from both sides. Then I'm going to have 1/9 x equals, I need a calculator. Oh, there's one. So I'm just going to say, what? 7/2 minus 26 over 9 and equals 11/18. 1/9 equals 11/18. And the same thing, I'm going to divide both sides by 1/9. So that cancels and leaves me with x. And then 11/18 divided by 1/9 is 11/2. 11/2, or, well, they have improper fractions there. If they start with improper fractions, it's okay to leave your answer with improper fractions. If they had mixed numbers, you would want to try your answer as a mixed number. All right. So the calculators make this very simple. All right. All right, I think we're to our special cases. All right, watch what happens right here. All right, variable on both sides. I've got to distribute that right there. 2x plus 6 equals 2x plus 8. All right, I'm going to move the variable to one side. Notice what happens, though. When I take 2x and I move it to the right, both sides it adds a 0, and I'm left with 6 equals 8. This is a special case. When the variables all disappear, you're going to be left with two options. You're either going to be left with two unequal numbers, or you're going to be left with two equal numbers. If the two numbers are unequal, this means that there is no solution. What that means is no matter what I put in for x, it's never going to work. Okay? Never going to work. All right? So that's one special case. That's when the x's disappear and I'm left with two numbers that are not equal to each other. All right, now watch, here's one more special case. Look at this one. I need to distribute the 6, so I'm going to have 4x plus 6 equals 6x plus 6 minus 2x. Here, I need to combine my like terms, so I'm going to have 4x plus 6 equals 6x minus 2x is 4x plus 6. If you notice something, I have the exact same thing on both sides. And then when I move the variable to one side, same thing happens. It disappears from both sides, but now I am left with a statement that is actually true. 6 does equal 6. This special case, the answer is going to be all numbers. In this case, no matter what I put in for x, it will always work. So the x's disappear and you have two unequal numbers. No solutions, two equal numbers, all numbers work. All right, I think that is it. Okay, easy enough, just simple solving equations. I'll add 4.2 to our assignment list, and then most of y'all or all of you have stuff to be doing.